Hi Spring fans, welcome to another installment of Spring Tips. This week I want to talk about something that'll help you get to production more quickly to better support that get, clone, run lifestyle. I love the get, clone, run lifestyle. It's the idea that I can take a piece of code, get, clone it, and then run it almost immediately, right? Nobody wants to have a tedious README or worse, a wiki page somewhere buried in a mountain of otherwise uninteresting documents about how to get started and how to on-ramp into a new project. Today we're going to talk about some of the incredible tools that are in Spring Boot to make that work, namely the Docker Compose and the Testcontainers support. And then, we're going to actually see how that is implemented underneath the hood. So get ready. Let's get started. We're going to go, as always, to our second favorite place on the internet, start.spring.io. Let's build a brand new application, start.spring.io. We're gonna call this simple, okay? And we're gonna use Java 21, we're gonna use Maven, and we're gonna use the latest version of Spring Boot. Now, mind you, these features have existed in some form since the 2.x line, but the particular support, the service connection support that we're gonna look at today, has been there since 3.1. So either way, these are not new features, right? They've been there for a while, but what we're going to do is take them all together and sort of see them in concert and see the details. So we're going to use this stuff. We're going to add, of course, Docker Compose and Testcontainers. Now, I need something. I need to demonstrate the point. I need to talk to something. So what I'm going to do is I'm going to use the PG vector database, and I'll use OpenAI, okay? So let's go ahead and hit generate and open this up in our IDE. Here we go. All right, so we have a brand new application, public static void main. I want to get to work on this code as quickly as possible. So right out of the gate, when I selected Docker Compose on the Spring Initializer, I was given a Docker Compose file for PG Vector. Well, PG Vector is a Postgres database with some particular plugins enabled. So it is a Postgres database, and you can actually see that we've got a custom label here to identify the service connection type so that when this thing is run, it's associated with Postgres. What does that mean for us? Well, it means that if I want to, for example, I can go here, source main Java and source main resources. Maybe I create a file here. I create a file called schema.sql, okay? And I'll say create table if not exists customer, ID serial primary key, name text not null, all right? And I'm going to tell Spring Boot to automatically run this when the application starts up. So I'll say Spring SQL init always. And then I'll create some sample data.sql. We'll say insert into customer, name, values, Josh, Cora, Dashan, and who else? Dan and Whitney. There you go. So there's some people in our table there. Create a Spring Bean that will, when the application starts up, inject the JDBC client and work with our data. So we'll create a record here. Okay, and we'll say JDBC client dot select all from customer dot query, and we'll say customer dot class dot for each dot stream dot for each. Okay, so pretty straightforward, right? I've got a JDBC client. Let me initialize that if I need to. So we'll inject that JDBC.data source. Here we are. Voila. Okay, so now let's go ahead and run this program. And remember, in my application.properties, I have no connection details here. So we'll start the program. And you can see it's using the Docker Compose file right there, starting up the program, initializing. Oh, it's complaining that we don't have a web server. Let's just go here and we'll add the Spring Boot starter for web. And then restart. Okay, so it's restarting the container, and there are our results. All right, good. So that took a long time, actually. Remember, I had to download the container and then restart the container. So one thing you might want to do is to, sort of change the life cycle. Maybe you want it to only start the container and not to restart it on every single rerun of the application. You can see it's that first time it took a long time because it was shut down. Now we run it again, and this time it's a far side faster, 1.84 seconds. But this is still, maybe this is not the fastest performance in the world. And so for this reason that I recommend you use dev tools, right? So if I go back to my initializer and I add the DevTools, then I can do a live reload and I don't have to restart anything at all, right? Usually Spring Boot is pretty fast, but I've got this interaction here with the Docker container. So this plus DevTools equals a really rapid experience. Let's go ahead and change our build to have DevTools in it. Okay, so I've added the DevTools dependency here. And now what I'm going to do is I'm going to restart it one more time after I delete the existing target directory. Okay, so it's up and running very, very quick this time. Notice that because the container is already running, it's cached, right? We're actually getting duplicative data there. So you might want to do something like deleting the data from the database before you restart the program. So delete from customer. Okay. All right. So that's fine. But what I want to do now is I want to change what it does when it prints out the results. So here's the customer. I can say customer : let's say, right? So that's pretty straightforward. I can restart. That's the wrong thing to do because that'll take a full 1.6 seconds. But if I say customer with a capital C and then do a recompile like that, Command Shift F9, that doesn't trigger a full recompile of the whole program. That's 0.49 seconds. So this is my favorite way to go. People move really quickly when you have a container that's up and running already there, and you've got DevTools allowing you to cycle very, very quickly as you make changes in the program. Okay, so this is great. This is the Docker Compose support. There's also test container support. So remember, both of these technologies are part of Docker, right? The company, Docker, develops both Docker, the Docker Compose, and test containers, which in turn uses Docker, right? So it's really just a matter of how you prefer to consume your containers. We have this nice support for test containers in Spring Boot as well. So if you look at this is our regular Spring Boot test. It in turn imports the test container configuration. That's this right here. And this is just a regular configuration class. It's got a special annotation just to make it very clear what it is. But it's just a configuration class. And it in turn defines a test container object, a Postgres container. It's a Postgres container. It's a Java DSL from the Test Containers project. And it's pointing to the PG vector Docker image, right? So this is not the standard Postgres /Postgres Docker image. It's a separate one, but it doesn't matter because it's compatible with Postgres, and so we can use the same container here, right? This is the queue that Spring Boot is looking for, is this Postgres SQL container type. Okay, so we've got the test configuration, and now here's our test main method. That's right, it's a public static void main in the test folder, source test, Java main. So it's a Spring application. Here's the main method from the production code, source main Java. But we extend it or augment that production code with some extra configuration provided by this test containers configuration class, which, like we said, is defining this bean of type Postgres container. Okay, so it's the same code as we have in production, plus an extra bean to define our Java object for launching a Docker image during our run. Okay, so we could use that same test containers configuration in our test code. We saw that here before, but also we can have a development time only main method that we can keep running just like we did before, what I just did before with the production code. So let's go ahead and run this now. So now I want to run this. The only problem is that right now we have Docker Compose and test container. So this is going to run, let's see. Okay, so now we have our main method. Let's go ahead and run it. Nice. So you can see there's our data. And we have the container PG vector being started and all that kind of stuff via test containers. Okay, so whatever way you work with, the result is a little bit slower the first time around, but they both benefit from DevTools. So you have a way to go faster and more readily without any problems. Now, in both cases, via test containers or via Docker Compose, we never specified a spring.datasource.url. We didn't specify spring.datasource.username. We didn't specify spring.datasource.password. We don't need to. In both cases, Spring was able to sort of figure it out for itself. And ultimately, it's doing that by talking to the Docker daemon on our local machine. And so if you kind of wonder how that works, then you're not alone. I also kind of wondered the same thing. So what we're going to do now, my friends, is build a simple application wherein we build an integration for another piece of infrastructure, a database called RethinkDB. This database is not supported out of the box by Spring Boot, and I really wanted to build a quick auto config and a nice integration for Docker Compose and test containers. So let's go ahead and do that. I'm going to create a project here called demo, and I'm going to use the Docker Compose support and the test container support and the web support. I'll go ahead and hit generate, and then I'm going to create another module called auto configure, right? And this is where our integration code will live. It'll be a module that we depend on. And, in theory, you could then publish that to Maven Central or to your organization's artifact repository. Let's open up both of them. Okay, so we've got our auto configure jar and our demo jar. We're going to use RethinkDB. It looks pretty cool. I've never used it before. I'm sure it's fine, right? I just wanted to look for something that would be easy enough to pull together an integration for Spring Boot for. So here's the project. Yeah, sure, go for it. Try it out. I don't know. It's probably fine. Seems pretty popular. And I thought, gosh, that seems like a thing I want to support. So we're going to go here. We're going to build a new application using that. So let's go to our demo dependencies here and add the RethinkDB driver, okay? And let's now go to our Java code and write a quick program that uses RethinkDB. I'm going to paste this in. Okay. All right. There's our program using RethinkDB. We can run it, but it's not going to work for a couple of reasons. First of all, what is this? And what is that, right? What is a connection? What is a RethinkDB? Where does that come from? Etc. And also, this is going to connect, presumably, to a connection. This is the connection here, a RethinkDB connection. But who's furnishing that connection? Who actually runs it? And this is the big problem, is we don't have that running infrastructure. We don't have that running infrastructure. If I go here and run Docker PS, you can see there's nothing there. So that's going to fail as well. So what we want to do is to provide an auto configuration to make it easy to stand up a connection to RethinkDB, and then provide integration with Docker Compose and test containers to make it easy to automatically stand up those containers when you have the right types in the class path. So let's go to our auto configure code. I'm going to delete some of the extra code in here that we don't need because it makes no sense. This is not going to be an application. It's going to be an auto configuration. Our build, for example, doesn't need the Maven plugin for Spring Boot because it's a jar, not an Uber jar. And we're going to need these things on the class path. So it's not just runtime. It's going to be optional for Docker Compose. It'll be optional for test containers, but we need them both, right? They're not test dependencies anymore. So I'll add those back in, okay? And then of course, we don't have any application.properties here since it's an auto configuration class. So we'll say RethinkDB auto configuration. So we have the auto configuration. Obviously, before we can go any further, we also need the dependency on RethinkDB. So let's go ahead and cut this from the demo and then paste it here into the auto configure jar and replace it in the demo with a reference to this auto configure jar, which will then transitively bring it in. All right, there's our auto configure jar. There's our dependencies. Let's go ahead and start writing the auto configuration for this. So here's the auto configuration class. You can see that we're not nearly done yet. There's a few things that are missing. First of all, here's the core RethinkDB object, but in order to do anything useful, you need a connection, a RethinkDB connection. So we need to actually specify that connection here. And we do that with this builder, passing in the host and the port. Well, where do those hosts and ports come from? Well, they're going to come from a connection details object. So let's implement that right now as well. Here's the core interface that we want to reference. And then we need a particular implementation of that interface for this bean type called a RethinkDB properties connection details. So it's going to be an implementation of this interface, this core interface, but that gets its values from a property file. So like, application.properties. Let's put that here. Here's the implementation, but of course we need the properties themselves, which gets us into the property binding. So I'll create a properties object here. Okay. So we're going to inject this now into our implementation like that. This.properties.host, this.rethinkproperties.port. Okay. So we're creating a bean, but only if there is no bean of that interface, that base interface type, anywhere else in the context. We're going to create this implementation that in turn draws its values from this configured configuration properties object, which in turn will draw it from application.properties or anything in the Spring environment. We're going to inject those values here and use them to create a valid connection. Okay, so this is all well and good, but we have to register this auto configuration in a factory file. So let's do that. We need to create a folder and then another one called Spring. And then inside this, we'll create a file called autoconfiguration.imports. And this file will in turn contain a pointer to our autoconfiguration class, like that. Okay, so that should be enough. So now if we go back to our demo application, get rid of these extraneous folders, and point this to the right host and port, and the host will be localhost. Now we should be able to run this and see these things furnished, and you can see IntelliJ seems to think it's going to happen as well. There's no more squiggly lines. So let's go ahead and start this up in public static void main, so not the test code, but we're assuming Docker Compose will kick up. Okay, so the Docker Compose support has failed because we haven't built that integration. So that's okay. Let's do it manually for the moment. Okay, so I have a file here which will run this bash script, and I have a bash script which will just run the Docker image in the normal way. All right, so we can see the client interface for clients to the database is 2805, 28015, and we've specified that here. So now let's go back to our Java code in the demo and restart it. It's complaining because it can't find a Docker Compose file. So for the moment, just to make sure our auto configuration works, let's go ahead and disable the Docker Compose file. Spring Docker Compose enabled equals false, restart. There we go. It's written some data to the database and then pulled it back out again. So if you look at the code, basically we're using rethinkdb. This is the object that we injected. This is the bean. Here's the connection with a valid connection to the container. We're dropping the database if it exists, and we're just ignoring it if it doesn't, and then we're running it, right? Then we're creating the database, and then we're running it. We're using the database, and then creating the table, and then running it, and then finally we're using the table and inserting a record, a name, Star Trek TNG, and then running it. And here we're then running a query to list all the data of that table, right? And I'm just visiting each map that comes back and getting out the ID and the name, and then printing them out, separated by colon. So that's what that is right there. And so it's working. We're able to write data, do some administrative stuff, and then pull the data back out again, all in one fell swoop. Good. But again, we had to manually set up the Docker file, right? And we had to manually run the container, and we had to tell Spring's Docker Compose support to back off because it's not going to help us because there is no Docker Compose file for it to run. So let's fix that. Let's make it so that this thing now supports Docker Compose. I've got a docker compose.yaml file here, but there's no rethinkdb container image defined here. All right, there's our simple Docker Compose definition. Spring Boot is going to automatically start that up. In order for it to work, we still have to leave this configuration in. Let's go ahead and try that out. Okay, so we got our Docker Compose file with the definition. One thing that's interesting is that IntelliJ thinks I'm working relative to the root directory of downloads. So I'm going to put this Docker Compose file there. Doesn't really matter. One of the nice things about Spring Boot support is it'll traverse upwards, finding Docker Compose files higher up in the tree so that it can try and make it work. Let's go ahead and start it out and see if it works. Hey, there we go. That worked. Okay, so we've got the automatic Docker Compose startup, but again, we had to specify this connectivity here. We don't want to do that. Okay, so we've got now our configuration, but we still have to specify these properties. We don't want to do that. Let's go ahead and teach Spring Boot about how to automatically stand up this Docker image for me via Testcontainers or Docker Compose. We're going to start with Docker Compose. Okay, so we're going to create a new class called a rethinkdb Docker Compose connection details factory. Here's what that class looks like. It is a Docker Compose connection details factory for rethinkdb connection details. It in turn manages a particular implementation of connection details for the sort of Docker Compose data, right? And that's this subclass. That's this class that's nested within our details factory here that will in turn do its work based on this thing called a running service. So we look at that implementation. It extends Docker Compose connection details, implements rethinkdb connection details, and in turn it derives the host and the port from the running service, which were given via this callback in the connection factory lifecycle. Now there's other things. You might have other things that you want available in this connection details object, like environment variables. Like our rethinkdb doesn't export any environment variables, but if we did, then we could get that as well. Running service.env, that's a map of environment variables, and we could use that to then figure out things like the username, the password, etc. Either the default ones or the ones that were configured in the image. Okay, so we have this here, and the next thing we need to do is to register this. So let's copy this reference. I'm going to go to our autoconfig directory and go here to metainf, and we'll create a new file called spring.factories. And we're going to put that in. We'll put that in like this, equals that. So it's in spring.factories. It's an org spring framework auto configure service connection details factories equals rethinkdb Docker Compose connection details factory. Okay. So we're telling Spring to automatically start this when the application starts up. And actually we can kind of see that in action here. So system out initializing this get name. All right, there's the initialization. You can ignore the bit that where IntelliJ thinks it doesn't exist or it's not being used, because it will be. At least it should. So let's go back to our demo now. And if everything's going correctly, if everything works, this new connection factory will derive the information it needs from the Docker image, which is going to be running in the Docker daemon, thanks to the Spring Boot support for Docker Compose. And so as a result, we don't need this configuration anymore. Let's go ahead and restart this. Okay, so you can see it started the Rethink DB Docker image, and it was able to connect. It had the host and port all figured out. Nice. That's very convenient, right? We have Docker Compose support. Now, what about test container support? Here in our test application, we've got a test class. We've got a test containers configuration, but there is no Docker image. There's no bean of type test containers here. Let's go ahead and create one. There's our Rethink DB container, and it's going to be using a generic container. We're not using the typed Postgres container or whatever container from Testcontainers, the project. We're just using a generic catch-all container. And because of that, we have to also specify a name, which gets matched up with the Docker container name for Spring. So this is actually special. You'll only notice that we're doing this when we're using a regular generic container. Okay, and we're also explicitly exporting the ports so that the Spring Boot auto configuration knows what ports we expect to be mapped. Let's go back to our test, our main code, our test code. Obviously, we want to disable the Docker Compose support. Let's go ahead and try running it. So we have our main class. Now we want to build out the infrastructure that allow it to work. So we've already got a Docker Compose connection details factory. Let's create one for test containers. We'll create a new class called the Rethink DB Container Connection Details Factory. So here's the implementation, same basic structure. We're telling it what the thing we want to find, what container we want to match with. We're telling it what classes are required on the class path before this gets validated. And then we're given a chance to produce an implementation of the connection details type. In this case, the type is now for test containers, right? So it's the same basic approach. We have a container connection details callback implementation. It in turn takes a pointer to the source, the test container source, and then we use that to get the host, to get the mapped port. And if we wanted to, again, we could get access to the environment variables, right? So get environment map and so on. So if we had something like that, we could do that as well. So this is pretty straightforward, pretty similar to what we had before. With this in place, let's go ahead and register it in spring.factories. Okay, so there we go. We got test containers. We got Docker Compose. Let's go ahead and restart the test main code. There we go. Look at that. It used test containers to start up the application. Right? You can see test containers infrastructure there in play. Ryuk, very funny. This is from that anime called Death Note. So here we go, creating the container for the image, Rethink DB, and starting it, and then we're able to get access to it and log into it and do things with it, all without the benefit of the username or the password. Nice. So now we have easy access to Rethink DB. We've created auto configuration. Naturally, the next step might be to create a starter dependency, so you can add the Maven dependencies that activate the auto configuration to that, but ours is simple enough that if somebody wanted to just access the auto configure jar and just put that in the class path, they'd get everything they needed. It has configuration properties. It has easy support and integration with Docker Compose and test containers, and it's easy to use. So this is a good experience for everybody who wants to use Rethink DB. Obviously, I've just created a bit of a toy here, right? There's a whole bunch of other properties around security and usernames and passwords and all that kind of stuff that I can and should probably integrate, but you get the idea, right? You understand now where to plug in what kind of values and what to look for and what the life cycle is and how to make this all work. Now you might be wondering, friends, I've got this really incredibly clean integration with infrastructure, but what if I have another microservice, another application I want to connect that's written in Spring Boot, or another Java application just in general? Well, I wouldn't use this. I wouldn't use this as setup. This is more about automating the integration of infrastructure in a reusable sort of way. But if you've just got another microservice, look into our project, Spring Boot Test Jars. This is a very convenient way to, sort of in the same way as you would with test containers, launch another Spring Boot jar as though it were a container, right? But it saves you the step of having to then factory a container and then consume it from another application. It dramatically improves the turnaround time. After all, you saw how quickly I was able to make changes between two projects within IntelliJ. Why can't I have almost that same exact sort of dynamic when depending on and launching collaborating services in my tests, right? Especially if those are just based in Java and they're based in Spring Boot. So Spring Boot test jars will help you with that. But if you're looking at infrastructure, if you want to provide a nice out-of-the-box experience for services and middleware and whatever, definitely take a look at this approach that we've outlined today. My friends, I hope you got something out of today's episode. You got to see how it's possible to have that git clone run lifestyle, to move quickly thanks to things like Docker Compose and Testcontainers and dev tools. And then if you want to, how to sort of act as a force multiplier, providing those same gains and efficiencies for other infrastructure and middleware that you and your organization want to use. Thanks so much for watching, and we'll see you next week.